switched it on. Okay. Hey, this is Swami. I'm recording the session. Good morning and greetings of the day. So thank you so much for joining this session. Is my screen visible?
Yes.
Yes. Okay, cool. So let's take real quick 1 minute to give you the links. The first one is this one, my GitHub link. And first, let me collect all these things and keep it. I'll give it at one shot, all these things. Some people who are coming little late in this session, they might ask it again. So this is the organization which I created separately for the session. I mean, the series. This organization is for the series. So I give this here. And this is the meetup group. Please subscribe to this. And this is a YouTube channel. I think you guys have the YouTube channel. So if not, please subscribe to this. And the next point I would like to discuss is this all the events which are being conducted. These are being conducted as part of the Microsoft Learn community. And I'm one of the member of this Microsoft Learn community. So each one of the member in this community will be given an separate tenant, so we can do all these events. So please join this group so we can have chat also. Okay, that's the thing. And let's start with today's topic. So what is that we are going to do today? So there are a lot of things. So let's start with this. So here also you can see I have uploaded all the documentation. I mean, if something is needed, I'll upload it again. But this is where we can see what is that we are going to do. A lot of things are there. So let's start with this here. A little bit I forgot to organize it. So this should come as 1, and these should come as 2. But I forgot to do. I mean, the 3 should come at 1. 1 should be 2, 2 should be 3. Okay, so that's my mistake. That is fine. So let's see one important thing here, and then we'll start. Let me go here to the working folder. All the time we use this folder for our tasks. So let me create real quick a new folder here. Call it as S3. That's session 3. There is nothing in here. I'll also open the terminal, which is very handy. So what is that we are going to do? Let me set the context. So we know the process of how the source code is getting compiled. So first we'll write the source code, and the Roslyn compiler will compile it, and then it creates the MSIL, and MSIL will be picked up by the JIT compilation. That process we all know. So now we'll see 3 out of those 4 steps visually. And the 4th step I'll be doing in the next session, because this itself will take a good 10 minutes plus to do this session. So verbally, I'll explain this, but we'll view little later. And in the next session, session 4, we will do that. Okay. So the session 4 is on. It's not on 18th. I'll reorganize because it's a festival time. 18th is festival time, so there'll be a lot of functions and loudspeakers. So I'll just reorganize the dates of the another episode. Okay, let's quickly start with this one. Let me come back here and let me take this copy and do CD. Okay, So the first thing what we will be doing is step by step, we will be creating a new solution in that. So all the documentation, everything, whatever I'm doing is uploaded there. So if it is something is missing, I'll do that. Okay. So let me close this so that I'll have a extra space. So let's do code. Now I'll explain what is that we are going to do. I just created this one piece and now let me set the context. What is that we are going to do in this session? So the first thing is we will see, we have written a little bit of code. Now we'll see the compiler and the default language, what we are using. And then we will do a deep dive into the MSIL and also the common type system and a little bit of common language specification. How is it possible for for different languages like C# and Visual Basic to stick to the game plan? And how is it possible for us to incorporate the code written in non-C# language? I mean, the code is written in multiple languages, but how are we able to communicate with each other? That's what we are going to do a deep dive on this one. And this verbally we'll discuss. So out of 4 blocks, we covered 3 blocks. This block we'll cover next episode. And then what we will do is we'll add multiple projects and then we will do create these resources. And then we will do a deep dive into the debugging process. How do you debug in Visual Studio Code? And we'll introduce what is variables. And when you create a variable, if you don't assign in a single statement, like the declaration and assignment, if it is not happening in a single statement, if it happens in multiple statements, what is that it's going to take? The default value, what is the compiler is going to assign? And the next thing is how do you accept input output? And this is section 8 is verbal discussion, and section 9 and section 10 is very much needed skill set when you have multiple versions of .NET on your box. That means if I do .NET -- list SDKs, if I do that, so I have .NET 6, .NET 7, and .NET 8. But you want to create a project with a specific version, either 6, 7, or 8. It's always the higher version always wins. Okay, the higher version always wins. So you can create it without giving, but if you want to create the project with any other version, at that time it is very much needed that you might have to take some specific steps to create it. So we'll look at all these things. Okay, let's come back step by step. We'll see 3. I'll reorganize this. Actually, this should be the first step. So we executed this, and then what I'll do is here is our entire work. For the next command, I'm saying that please create a project called A1 compiler version. So it created another project, A1 compiler version. And then I'm telling that go add this project to the solution. So if you come and see that, it gets added to the solution. If you come and see that particular project has been added to the solution. And then what we will do is we will do a real quick .NET Restore and .NET Build, and then we will run that project. There's nothing in that, but we will execute it. When you run, it is displaying the hello world. Now it is all is well. So let's come back to this location. And if you please, now the tooling, from the tooling perspective, nowadays, every company, they are providing a lot of enhanced tools which we can't even imagine that these kind of tools are coming out, the support. If you see this Visual Studio Code itself, you don't need to go anywhere out of this. So you will have Azure, you have got Kubernetes, Docker, and you have testing, and you have remote explorers, and you have GitHub Actions, and you have MySQL, Kubernetes, MongoDB, SQL Server, database project, Terraform, AWS. I mean, you name it, you have those kind of things. Everything is being provisioned here. You don't need to go anywhere at all. So that's the kind of enhanced tooling we are getting nowadays. Okay, that being said, let's come back and let's copy this code and paste it. So what is that we are doing is we are trying, because I told about the 4 boxes. So let me take the point and I'll show you the 4 boxes. So here, let me create a new slide. And the first box, I'm taking it as the source code. This is the source code. And the second box, the source code, will be taken by a compiler and it generates an MSIL. I need a 5th box, so I'll move this a little bit here. And I'll move this one a little bit here. And this is intermediate language. And then there will be a couple of other process, there will be one more process. I mean, recently they have introduced ahead of the time compilation, but we will worry about this one, JIT compilation. And this JIT compilation will create the machine specific instructions. Okay, this is I'm showing in zeros and ones, so something like a machine specific. So out of that, we will cover these 3 boxes. Okay, so these 3 boxes will cover today. So I'm storing this as a first box. So right now, whatever we are seeing here is the first box, source code. So when we go and do .NET build, when we do a .NET build, this is the compiler, Roslyn compiler, and this compiler is taking our source code and converting into machine language. So this is the compiler. We will just see this, and again we'll come and we'll discuss about few things. So we saw that the compiler took that and it was able to compile our code into machine intermediate language. It's not machine specific instructions. It's one step on the left. Okay. So if you have any queries, please let me know. So that's the compiler. So how do we know that this is what it is happening? So before doing this deep dive into that IL, let's see that what is that compiler language? How do you figure it out, that what is the compiler version and the language version? Because it's always the framework version. In the C# project, you will know that what is the type of output and the framework version, and some other the language versions you can specify here. And one thing to know very specifically, what is the version, compiler version and the language version, you have to write this pre-processing directive hash error. I'll show you that. What is this one? This is the preprocessor directive. Hash error directive. Okay. So if you see this one, you have a lot of this. You have this lot of the preprocessor directives are there. So one of the preprocessor directive is hash error. Lets you generate an error from a specific location in your code. So once this, if you put this line, I mean this preprocessor directive, so it blows off your code at that location. So another advantage of that is if you want to know the version number, so it gives you the version number. So after uncommenting that, if I come and execute this project, and let me comment this back, and again I'll execute this project. I executed this project. It is the one which shows that it executes it. Suppose if you uncomment that line, so it throws an error as we have seen that, and you will see the compiler version is 4.8. This is the compiler version, and the language version is C#11. So this it emits. So now we have seen the second block also. We saw the source code block is this one, and I'll tell that uncomment the below line. After this, it makes more sense to uncomment the below line. See the compiler version. I'll put that also here so that anyone who's running, it will be easy for them to understand. Let's see that. So if someone executes, it's very specifically, it will tell that, hey, please go ahead and uncomment that line. And if you uncomment, you will see this. So we saw that what is source code. The source code is this one, .cs file. And we saw there's someone called compiler who's taking this source code and creating the MSIL. So now let's do a deep dive into understanding the MSIL and the path where that is stored. That also we have seen in C working directory under bin debug.net 8. It's the DLL version. So for that, we need to go to the developer command prompt, or anywhere you will have access to the ILDSM. So intermediate language disassembler. That's a full name of that. So first one is we have to understand what is compiler. So this should be at location 1. I will reorganize this, and then now we will come and see that. So the previous project, whatever we executed, the previous session code, let's go to that. So if you see here, we had, why do I need to see my face? Here we have two things. We have written a library in C#. We have written a library in VB.NET, and then we have organized this at the bottom. Oh, don't you allow me that to do it? Come on. Okay, that's cool. Is it possible for me to drop it here, or I think I'll drop it here. Why is this? Okay, now it's cool. So we're able to see all these things. So here is the C# library. Very simple library. It has got one static property, one static method, and one instance method. And we'll come back. Don't worry about those things. I'm going to explain step by step in future episode. Now you see this, we have another library in VB. So it has got a static member variable and a static method and an instance method. Now in C# program, we are able to use the VB.NET library as well as C# library. How is this possible? So that because the compiler, whatever the language you write it, maybe C# or VB.NET or something else, that code, source code, is compiled by the compiler into an intermediate language. So it's a common language which is understood by all the .NET compliant languages that we have seen. All the links, I've given all the links. So just to save time, I'm not opening all these links, but at least I want to open one link where we'll see the process here. So here, if you see, we saw this step, this and this. I mean, we didn't do anything in F#, but we saw C# and VB.NET code. And respective compilers are compiling this code into common intermediate language. And JIT compiles to binary. That we will see in the next episode, because this episode this was covered in previous 2 sessions. We covered the compiler thing now, and now we are doing a deep dive into the intermediate language. So let's do that. So for that, we need to go and open ILDASM. So it's called Intermediate Language Disassembler. I'll open 3 instances of that so that we can place what? Okay, you're playing with me. We have 3 instances. I'll place everything side by side. And the third instance, where is that? This is the first instance, second instance, and third instance. So we have 3 instances here. So now what I'll do is I'll just go and open the first one. Is the C# library. So we know that it will be here. Okay, VB.NET has come first. Let's open that, VB.NET. And the next thing I'm opening is the C# library. The CS library, I'm opening it, bin debug. And the third one I'm opening is the project itself. That's in C#. It could be in any other language. It could be in F# also, or any .NET compliant language. So that is here. Okay, so now you can see one-on-one with this. Okay, I'll place it here. So you see, this is a C# code, and it is IL code is here. This is the VB.NET code. Its corresponding intermediate language code is here. This is the C# console application. Its corresponding intermediate language code is here. Now let's focus on one specific thing, the max value. In C#, the max value is declared as int. But what is that it is doing? The common type system which was created by .NET is int32. So its alias is int in C#. So here it is integer. In VB.NET, it is the data type is integer. But what is the common language type is? Common type systems type is int32, which is called as integer in VB.NET, and it is called int in C#. It might be called something else in some other language, but what is very common? The common type system type is int32. Okay, so if you further, you can dig deeper, add numbers. So this is the code which we have written, which is 2 ints and it's returning, and this is 2 ints it's returning. You can double click on this add numbers since instance type. This is coming from the C# library, folks. Please understand. And let me double click on this one. Is there any difference? See that add numbers in 32A, in 32B, CLI managed, and stack locals in 32V0, in 32V0, NOP, IL dark, load argument 1, load argument 2, and you're calling Mac. It's some kind of allocation, I assume. But if you see net, what is happening is, even though you write it in any specific language, you take any specific data type, it's all compiled into intermediate language. So that is the reason when you write the code here, when you write the code here in C#, see this, you are able to call the vb.net library here. See this, it created the new object. At least you can see the new obj. And then there should be an invocation call to that line where we are calling this the constructor and some literals here. Yeah, here. See this, the vb.net library, it's calling add method. It's passing int32. And similarly, there should be a C# code, libraries code. I think, yeah, this is the one, C# library. Its instantiation should be happening somewhere here. And if you dig a little bit deeper, and it should call, see this, add numbers. In C# library, it is calling add numbers. And again, it is passing int32. So I think now we did a deep dive into this piece to understand what is that which is making possible to speak between this language. I think now I can open this link. You people will better understand this, the common type system. So if you see this here in this common type system, you have a lot of things are there. No, I just wanted to show you something else, not that link. Yeah, this one. This is the link I wanted to show. Yeah, come on. This is the link I wanted to show. So if you see that, the .NET has created int32. Okay, so what is that int32 called? In C++, it's called as int. And in C#, it's again called as int. Let's see that. In C#, it is called as int. And in VB.NET, it is called as integer. And in F#, I think based on the value, it is assuming it. But net, what is that we understood is, you should understand this. Whatever the language you write it, the respective compilers will compile into a unified language, that is intermediate language, the common intermediate language. That means everybody understands that. So that's about the common type system and the common language specifications. I mean, all the .NET specific language has to adhere to the rules of the game. So that is what it is making it possible for different languages to speak. So I think we understood this box also to a decent extent. Correct me if you have any queries, we can speak now. Okay. To a decent extent, we covered these 3 blocks. This I'll cover verbally now, but we will do a deep dive like this. I want to show you under the hoods, deep into the weeds, like what is that which is happening? How does it compiles? I want to show that because that itself will take a decent 10 to 15 minutes time, as this has taken a 10 to 15 minutes decent time on that one. So I just don't want to show both the things and overload you. So these 3 blocks we have covered. Now JIT compilation, what it will do is it will take this intermediate language and then it will compile into machine specific language on the fly. So what happens is, if you have this method, just before calling this method, the JIT compiler will go and compile this from intermediate language to that specific machine on which you're running using the JIT compilation process. Suppose you have 2 methods, add numbers, multiply numbers, and you have never used multiply numbers, but still it's there in the library. the compiler will compile the source code into intermediate language. That is mandatory. It compiles everything which is there in your source code into intermediate language. Now, the JIT compiler is a very intelligent compiler. What it does is it looks at your code. That means this library, the entire source code, it goes and it verifies, hey, did you call these add numbers? Yes, you called it. So then it, just before calling that method, it goes and quickly compiles only that portion of the intermediate language into machine specific instructions. So that specific block of instructions, and multiply numbers which you have never called, but it is there in the source code and intermediate language. So JIT compilation will not spend even a single second worrying about that method because it was never called. So it is not going to convert that intermediate language into machine specific language. So this way what happens is you're saving time and you're compiling, or you're spending time only on those methods which are invoked in that specific code. If it's not invoked, it's not going to spend. That's one advantage. Second advantage is the JIT compilation happens only once. That means add numbers is called. So it spends time to compile that to machine specific instructions. That's it. Once it is JIT compiled, and you're calling this method 1,000 times. So you don't need to, the JIT will not spend even a single second on that for 999 times because it JIT compiled. It will have this in its history that this method has been JIT compiled. So it will never ever come back and JIT compile it. And the method you don't use it, it will not even worry spending even a single second time. So that was one of a ride of those key points. Now we understood these three blocks. I will close this. This we will do. I want to do a hands-on. I mean, this just I gave you an introduction so that in the next session, I'll show you how this happens. That is under the hoods and deep dive. Okay. This itself was a pretty deep dive to understand. So we saw that source code, we saw the compiler version, and then we did a deep dive. All the things are there. Just please understand that. And we did the deep dive into finding out how the IL is there and how to view the IL and what is that which is making possible to consume the code written in different languages. And also we did, at least verbally, we did a deep dive over this JIT compilation process and the advantage we have seen it. Recently, I mean, from .NET 8, I assume, I'm seeing ahead of the time compilation. I never tried it, so once I try, I'll let you know. So this one also we have seen it. So now let's discuss about creating multiple projects, and we'll do deep dive into the debugging process. So let me come back to this folder where we have this one. And this is also there. Let me come back here. And this should be good. Now let me go ahead and create the multiple projects. So let me execute this step by step. I'm creating another project to showcase a little bit of about the variables. We'll see that. And then we will do deep dive into the debugging process. Okay, I think I need to bring that. Looks like someone is here. Okay, so guys, you guys missed a couple of very, very important deep dives which we did it, but please watch the recording. Okay. Just give me a minute. I will copy this, reveal in File Explorer. I'll drop this working. Okay. So now okay, we are here inside this, and we do dot will come in here. Dot will take it here. Common header footer. Could not find any project in this one. Why? It's clearly there. The common is here. Okay, let me open this terminal one more time. Maybe it's not recognizing that. Let me navigate to this folder. And get the command from here. Get the command from here. And before that, let me verify that. Ooh. That's what it was telling that. Why it doesn't show that? Let me open the terminal. Yeah, it is there now. S3. Perfect. It's there. Let me close the other terminal. We have already seen the demo. Now let me come back to this folder, and what we are telling is add .NET reference ... That means from S3, I'm coming to the parent. From S3, I'm coming to the parent. And I think it should be only one ... not two. Because that's only a export. Why cannot find any project in C working S3? Why not? Oh. Project. Okay, so what are the steps which we did? Just give me a minute. We added this. We have created this. Where is that I created this project? It's here. And we have put the projects. And did we execute this? I think I executed this command also. I'm sure. Access that already contains. And now here I do have two projects, and they are ... So I have common here in this one. So what I'm telling here is add. Oh, sorry, it was my mistake. So actually, I should have gone into A2 library, and I need to execute this command from here. This third command. That was my mistake. Sorry, guys. So I'm executing it. So now it adds the library. Now I can come back to this one and do a .NET build. So now it builds the three projects. So the first project is the compiler revision project, and the second project is the header footer, and then it builds the A2 variable demo. Why? Because the A2 variable demo depends upon this library. So first it goes ahead and builds the library before building this one. Okay, so that's good. And second, we'll create this project also, and then we'll execute all the projects. I'm building the third project. Sorry, I'm creating the third project. The third project has been created. Now I need to add this third project into the library. So it's there. So now I go to that A3 demo. So we are here, and then I will go and add the reference to that. It's there. Now I come back here, .NET build. It goes and builds this. Now we have the working version of all the code. So it built the header footer library, and then it built A1, A2, A3. All three are console applications. This one is library. Don't worry, we'll come back a little later to find out what is library and how to work with that. So now let's switch back to the VS Code to update this code. So what is a variable? We'll discuss about it, and then we'll come and we'll do the debugging. So the variable is a named memory location. So each variable will have a size. That means what is that it can store? Can it store unlimited values? No. So we have each of the data type will have its own size. That means the number of bits it's going to occupy. Like 8 bits is 1 byte. So if you have 1 byte, what is that values it is going to store? And each of the data types, what is the maximum and minimum values it can store? And what is its default value? So as of today, we'll learn that variable is a name location. It can store a value of some specific type. We have to give them a type, very strict on types. Like we have to tell that what is that we want to store. It's not like the dynamic typing where you can go and create a variable, start initializing with string and then modify it into an object and then modify it into a Boolean variable. We can't do that. So we have to be very specific on what is that we want to store. So that's very important rules. So next session, when we come and discuss, at the time we'll discuss what is the minimum value, what is the max value, and some of the members, how do we access the members, how do you call the methods. We'll do a deep dive there along with the JIT compilation. Okay, so now what I will do is I will go ahead and copy paste the code so that it will save us a lot of time instead of going ahead and typing this entire code in front of your eyes. It takes a lot of time. This we will use it for the debugging purpose also. Now it's the right time for us to do a debugging. So what happens is here, if you see the code, here we have declared few of the primitive types. We'll come back to primitive types and other things in the next session, but just wanted to show you different data types like integer. And again, we can do a deep dive, folks, here, which I'm a little hesitant to do now, but we will do it a little later. So we are defining the variables and we are not assigning anything to this. So that means what happened is based on each data type, they have the default value. So int is 0 and the char is null string and string is empty string, null. It's null and this is false and decimal zeros. So we'll see that how it is there. And then here we are assigning values. I could have done this in the single statement, int age equal to 18, but I want to show you if you don't assign anything, what is the default value? And you can't use that variable. It throws an error before assigning the value. If you try to use this, And let's come and try executing this .NET run project A2 and A2. So it says that use of unassigned local variable. So until you allocate something, you can't execute it, right? So now is the time for us to do a deep dive into this one. Now, debug project associated with this file. So we are doing a debugging. Oh, I have to create the project assets. Generate assets to build and debug this project. Oh, sometimes this guy. Actually, technically we should see one of the this solution explorer, which it is not, but never mind. Let's do it manually. So let's create, actually what happened is once we select that, it should go and show that. But why is this not? Why is that it's not generating? Okay, never mind. So let's see, we'll create a folder called .vscode. And inside this, we'll create a file called this settings.json, and inside that we'll paste it. Maybe after this it will recognize, I assume. Let me paste this, and I will close this. And now let me close this folder and again reopen it. I think now it will recognize. Let me open this project again. Open the folder. And I'm opening this folder. Once I open the folder, it knows that what is the solution. See this one by one, all the extensions will be activated. And now if I go to this particular project over here, to see this, now it is loading this project. Now it has loaded this project and it recognized all. Okay, so that was the thing. So now it recognized all the project, and let's give this another shot. Let me open. If not, we'll manually create it. But technically, the tooling is changing every day in, day out. See this now, it recognized that. I'm saying that, hey, I just want to execute this project. So it will create tasks.json as well as the launch.json. So it is adding that, what is that we are going to do that. So I'm saying I'm just giving the project name instead of having that default text. Okay, now that has written for one project. Now if I want to generate this assets, I can generate the assets. Okay, now I'm saying that I want it for this 2. Now let's see that. So now we have, it has written for 1 and 2, or did I select 3? I don't remember. But the good thing is, for each and everything we can generate automatically. What I'll do is I'll just copy the one which is doing for all these three projects, which already have created. So you can see that A1 compiler version and variables demo and output. So I just created these things. I mean, I showed you the process, how will it create, but manually also, if for some reason the tooling doesn't work, we can go ahead. So the catch is create a VS folder and settings file, reopen it. Then the VS Code is recognizing this folder and this project, and it understood that, oh, there are three projects, and it created the tasks.json, which technically tells that go and build this solution. And after that, in the launch.json, you're telling that which project to launch. So that's something which you need to understand. Now let's come and do a deep dive into the debugging. So I just placed it here. So here we can see that run our debug the project associated with this file will enable it. And there are other things which I wanted to show you. This is one way to do it. Okay, the icon over here. And the second way to do is you can directly come here and see this drop down list. It shows that what all the launch task.json, this is coming from the launch.json, what all the launch configurations which you have specified will be here. You can select the project which you want and then click on this start the debugger. So the debugger will start. And once the debugger starts, so there are four important pieces, blocks or windows are available here. The first one is where all the breakpoints which you have placed. So in the program.cs, it shows that on line number 18, we have placed it. So by seeing itself, you will know that at how many places you have written the debugger. Okay, you can toggle, but the key thing is it will give you this information. And this is very important, the call stack. When you have a bigger project where project A is calling project B and B is calling C, C is calling D. Now you need to know that what is that which is being passed from A to B, B to C, C to D, like that. So this call stack will give you the full information as who called whom, what are the values which are coming, at least at the specific thing. What I would look is who is calling whom. The hierarchy, the stack is very, very important for us. And watch window is you can add any specific variable or any expression, you can add it here. Suppose you want to watch on any object, like I want to watch on this header. That it shows that what is this header, and this is a binary code. I mean, which we will see in the next one. I don't want to derail this session today. So we'll see this binary JIT compilation and other things. We'll do a deep dive. And here, the variables, as I was mentioning, when you don't assign anything, this is 0, this is null string. Okay, /0 is called null string. And this is null, this is false. All the numerics are 0. Now, here is, I do F10. Watch this place, guys, please. So when I do an F10, see that age has changed to 18. And gender has changed to M. Its ASCII code is 77. And John Doe. And this is true. That's a salary. This is a bonus. And rest of the things I'm just executing it. That's it. So if you come and see this, you will see that in terminal. Now that we understood how to debug, let me go and execute it here. So you will see that it executes it one shot. Right? So that's about the debugging process. So did I miss anything? Yeah, one thing I want to show you. Couple of things I wanted to show you. One thing is the C# library. We'll go into that call stack one. Before that, let me do this. The third program which I planned it for today is this input output demo. Let's see this. Here there is one important tip I have to give. So all the write lines will display, read line will accept. So if you see when you place the mouse cursor on the read line method, it returns string. So anything you read it out of console is pure string. Now you have to convert into these types. We will see that in the next episode. But as of now, you understand that this is what it is. And another important thing is if you are finding, if you have anything input from the console, you might face some problem. Suppose if it is internal console, let's see that how we will face the problem. I will place the cursor over here, try changing this to input output demo and execute it. So now it starts the debugger and it comes in here. And oh, sorry, I should have changed it. The title is wrong. And it displays the thing, but there's no way I can give the input. I struggled a lot. What is that mistake I'm doing? So please ensure that if you are in a situation where you need to do it, you can use the external terminal or internal. That shouldn't be the internal console. That's the default value. So now if I have this, now let's go and execute it. Now see the difference. So this is one tip, because we'll waste at least few minutes time. Now it comes in, it stops properly. See that? Now you see here only age has been assigned. Now rest of the things are, because these all are strings and everything is has to be executed. So just be male and manager is true and salary. I mean, this is all string, guys, just understand. And this is 0.03. Okay, it is displaying. This is a simple one. Another important thing which I would like to showcase is about the call string, which is very, very important, folks. I do have it here. So let me switch to the integrated terminal of the -2 and I do a code dot so that it opens up in a new window. And here, let me close this and let's see this. I'll place a debugger over here. Let me go back and select the version 3 and start the debugger. So it's starting the debugger. I mean, all the source code is there and the documentation also. So you guys have been covered. So anything you see the video and you want to replicate, you're more than welcome to do that. I mean, please, I'll suggest that please do it. So that way it will be easy for you to understand what is happening in the next session. Why? No, don't do that. Let me close all these windows. It says that it's locked. Someone is locking it. Oh, we have opened it. Let me close this window also. We have opened it with the ILD disassembler. That might be creating some issue. I'm not sure. It could be. I don't want to speculate. So that could be reason, but let's do another try because I wanted to show you that call stack is very important concept. I don't want you guys to lose it. Okay, so the third one, and if not, we'll do a clean build, or else I'll show you in the next episode because now it's 10:01. I think we can stretch for 1 or 2 minutes. Looks like it is locked by the IL disassembler because we opened these libraries in the IL disassembler. That's the thing which is troubling us. Now, don't do that. Let me come in here. .NET .NET build. Right. So still it is locked. I think because of that. But anyways, I'll show you this in the next session. So that's it from my side, folks. Hope you guys have learned something new. But Sam, were you there from starting? Did you get a chance to see the debugger and the compilation process?